Moving on to section 5.4, we're going to deal with compound interest today. This section will probably have 2 videos to it. You'll notice here this is labeled number 9. Don't be alarmed that there's no 7 and 8. We did that kind of in class live. Section 5.3 would have been videos 7 and 8, so don't be caught off by the skipping. We're going to talk about 2 concepts today, the first of which is this huge formula, which eventually you will need to memorize, so it's important to understand what the parts are. The interest we talked about so far has been compounded annually. So, for example, your money sits in the bank account for a year, and then they apply the interest. Well, interest can be compounded more often than that. It can be compounded monthly, daily, weekly, a lot of different types. So this is where that formula comes from. Your A is still the same as it has been. P is taking the place as A0. You'll see here it says, sorry about that. You'll see here it says it takes the place of A0. So that's the same function. It's your just initial amount. Other things that stay the same are R is still the interest rate and our T is still time. It's the N here that is really changed. So N is the number of times per year that the interest is compounded. For example, if it tells you that interest is compounded monthly, there are 12 months in a year, so your N would be 12, and it goes in both of these places. So this is the formula we'll be using. We actually have been using it all along, we just didn't really tell you that. If you look at this and think about it annually, if N is 1, and I get rid of these 2 N's, what we're really left with is P times 1 plus R to the T, and that's the formula that we used in videos 3 and 6 from sections 5.1 and 5.2. So here's an example where we can actually use this. So Kevin is depositing the coins in his piggy bank into a savings account. The bank's offering an interest rate of 2.5%, so we know that's an important piece of information. It also tells us that it's being compounded quarterly. Quarterly is 4 times a year, every quarter of a year, every 3 months. After rolling the coins, he discovers he has $514.86. That's going to be our A sub 0, or now we call it our P. And it's asking us how much he'll have when he graduates college 5 years from now. So we're using this formula over here. I shrunk that down for you. So let's see how this works. We're going to have A equals, we know our principal amount is 514.86. Inside the parentheses, we need 1 plus. Our R, we know our rate here is 2.5%, so we can put 0.025 here. Over N, again, we said quarterly is 4 times per year. So N goes in 2 places, at the bottom of this fraction, and then up here we need another 4. So here you can see we have N times T. The time they gave us is 5 years from now. So up here we have 4 times 5. That may be easier to see with parentheses so you're not thinking it's 4.5. That's what you're trying to enter into your calculator. So if I do that, the 0.025 divided by 4, that's all being raised to the 20th. And when I multiply that by our initial amount, that means in 5 years from now he'll have $583.19. So the Formula 1 is difficult to memorize, but once you figure out what goes in what place, it's pretty easy. It's just a plug and chug into your calculator. The last thing we're going to discuss in this video is called effective annual yield. It's also known as APR. You may have heard APR financing on car commercials and other types of financial calculations like that. How that works, it's a change in amount in 1 year. So what you need to do is compute what happens in a year to the money and subtract it from the original, so you only want the difference, and then you divide that by the original. So if we look here, Jeremy wants to deposit his earnings over the summer, in which he made $3,549 into an account. So important piece of information here, we have a 5.3% interest rate. Our principal, or our initial amount, is $3,549. And we know the interest is compounded quarterly. So first we need to take a look at what happens in a year. So we have our formula here is P and then 1 plus R over N and N times T. So our principal amount is $3,549. Then we have 1 plus, our interest rate is 5.3%, so we'll write that as 0.053. It's being compounded quarterly again, so our N value is 4. And then up here we have 4 for N, and since we're dealing with effective annual yield, we want to figure that out for 1 year, so that's all we need for that. When you plug that into your calculator, you end up with $37.40 and 87 cents rounded. So all that tells us is what happens in a year. So at the end of 1 year, you have $3,740.87. In order to determine our APR, we said with our formula, we take what happens after a year, so 3740.87. We're going to subtract the original, which is 3549. So that top is the change in a year, the difference in a year. And we're going to divide that by 3549. So 3740.87 minus the 3549, our difference in a year, so we made, or he made, 191.87. When we divide that by the original, 3549, we end up with 0.0541. We can also write that as your percent, 5.41%. So that's your APR, 5.41%. You could leave it as 0.0541 if you wanted to. Just taking a quick look to compare that, that's a little bit bigger than our 5.3%, which is why the car companies will advertise that, because the interest rate looks a little bit higher. So the effective annual yield there is 5.41%, while our original interest rate in the bank was 5.3%. Some of the problems you'll see for this ask you for different things, like they'll give you the end amount and ask you for the interest rate. My advice there is just to write down the formula you need, whether it's this one here, the compounding interest, or the effective annual yield. Fill in the pieces you know and then try to solve for what you don't know. But with this information, you should be able to do all the problems in the worksheet, the 5-4 worksheet I gave you yesterday.